Enzymes are molecules that increase the rate of biochemical processes, and almost all enzymes are proteins. Today we will look at 10 enzymes that make possible the 10 steps in the breakdown of sugar. This process is called glycolysis. This molecule is hexokinase. A kinase is an enzyme that attaches a phosphate group to another molecule. The enzyme isn't changed by the reaction, it's just the agent of change. Hexokinase captures a glucose molecule in its active site and holds it in just the right orientation, like a robot arm might do in an automobile assembly line. It then takes the last phosphate group from an ATP molecule and attaches it to the glucose. Glucose and ATP go in, and glucose 6-phosphate and ADP come out. This enzyme is phosphoglucose isomerase, and its job is to change the shape of the molecule we just made. It takes the glucose 6-phosphate and shuffles a few atoms and makes fructose 6-phosphate. This is the step 3 enzyme, Phosphofructokinase. It captures the molecule we just made, as well as another ATP molecule. Then it transfers a phosphate group from the ATP to the fructose 6-phosphate, producing fructo 1,6-biphosphate and another ADP molecule. At this stage, the sugar molecule is primed, and the cell is ready to start breaking it up. This molecule is fructose 1,6-biphosphate aldolase, and it cuts the molecule in the middle, producing two similar pieces, each with a single phosphate attached. This enzyme has multiple subunits. Now, while the two halves of sugar are very similar, they are not identical. This molecule, triose phosphate isomerase, will change the shape of one of the pieces to be identical with the other. And we end up with two molecules of glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate dehydrogenase is another enzyme with multiple subunits. It will add one more phosphate to each glyceraldehyde phosphate. Now at step 7, we are ready to make some ATP. The glucose has split into two halves, each of which now has two phosphates attached. Phosphoglycerate kinase takes each of these molecules and transfers one of each of their phosphates to a pair of ADP molecules, creating two new ATP molecules. The last 3 steps of glycolysis will remove the remaining phosphates from the two pieces and use them to make more molecules of ATP. Phosphoglycerate mutase begins this final capture of energy by shifting the phosphate from the end of the molecule to a strategic place in the center. In the 9th step of glycolysis, the cell places the phosphate in an uncomfortable position, making it easy to remove to form ATP. The enzyme enolase removes a water molecule, forming a new double bond in an awkward place in the carbon skeleton of the molecule. This enzyme contains two identical active sites. In the last step of glycolysis, the cell is finally ready to make a net gain in ATP production. Pyruvate kinase removes the remaining phosphates and places them in ADP to create new ATP molecules. This allows the unstable little sugar fragments to rearrange into stable pyruvate molecules. These pyruvates leave glycolysis and are subsequently burned up completely into carbon dioxide and water, or converted into throwaway molecules like alcohol or lactic acid. Here is a visual review of the 10 enzymes and the intermediate molecules they produce.